The second hand of this clock is 0.16 meters long. Find the angular speed, angular acceleration, speed, tangential acceleration, centripetal acceleration, and the acceleration for the tip of the second hand. For angular velocity, by definition, the average angular velocity is delta theta over delta t. This is the average angular velocity. And the second hand goes around at a steady speed. So this average angular velocity is the angular velocity at any moment, because the second hand is doing constant angular velocity motion. So this is delta theta over delta t. We know that the second hand goes around one circle in a minute. So it's one revolution in a minute. So it's one revolution per minute. But if we want the angular velocity to be in standard unit, then we don't want revolutions, we want it to be in radians. One revolution is how many radians? It's 2 pi radians. And 1 minute is 60 seconds. So this will be pi over 30, which is 0.105 radians per second. And what do you think alpha is? We know that average angular acceleration is delta omega over delta t. The second hand does constant angular velocity motion because the tip of the second hand goes around at a steady angular speed, and it's in the clockwise direction. So same angular speed, same direction. That means the angular velocity stays the same. The angular velocity doesn't change, so there is no alpha. Alpha is 0. And then we want the speed. When we say speed, we mean the meters per second, that the translational speed. If we want to talk about angular speed, we would say it's angular speed. So when you see speed, that's referred to the meters per second, that kind of speed. So we want the speed. This second hand is rotating about a fixed axis. So we can say the speed equals to r omega. For the tip of the second hand, the r is the length of the second hand, so it's 0.16. And then the omega is 0.105. So we get the speed is the standard unit, 0.017 meters per second. And then tangential acceleration. Tangential acceleration is responsible for speed change. The second hand goes around steadily. There is no speed change, so the tangential acceleration is 0. Of course, the tangential acceleration also equals to r times alpha, which is, of course, 0 because alpha is 0. And then centripetal acceleration, which is v squared over r, and it is also r times omega squared. For the second hand, the tip of the second hand is 0.16 meters from the axle. So the r is 0.16, and we have the omega 0.105 squared. So this gives us 0.0018. This is the linear acceleration or translational acceleration, so it's the same meters per second squared. Now the acceleration is like the total acceleration. The acceleration has two components. The tangential acceleration is supposed to be tangent to the path. Centripetal acceleration goes towards the center. These two, they're perpendicular to each other, the two components of the acceleration. So if you want a total acceleration and these two are the components, then the magnitude will be the square root of the first component squared plus the other component squared. So this is 0. And so this is the square root of centripetal acceleration squared. So this is the centripetal acceleration because there's only one component. This one is the non-zero one. That component is 0. So total acceleration is the centripetal acceleration, which is the 0.0018 meters per second squared. What if we have to find these properties for the midpoint of the second hand instead of the tip? The entire second hand rotate together. So every single point on the second hand has the same rotational motion. Therefore, every single point on the second hand should have the same angular velocity, same angular acceleration. But the midpoint has a different r, therefore the speed would be different. The midpoint has half the r. Since omega is the same, that means the speed is half of that value. And then tangential acceleration, of course, it's still going to be 0 because the midpoint of the second hand goes around at a steady speed, no speed change. So tangential acceleration still same as 0. What about the centripetal acceleration? Centripetal acceleration is r times omega squared because the midpoint and the tip, they have the same omega, so it is easier to use the r omega squared instead of a v squared over r. Omega squared stay the same, so this is proportional to r, and r changes by a factor of 1/2. Therefore, the centripetal acceleration does the same. And the acceleration is the centripetal acceleration only because tangential acceleration is 0. So that means, of course, the acceleration also changes by a factor of 1/2. So it's half of that value.